Okay, today we're on page 16 of their notes, and which is about sampling error, and more specifically, we're going to stress the difference between sampling error and bias. All right, the difference between sampling error and bias. Bias we said bias is when you have a sample that overrepresents or underrepresents a part of the population. We also said that bias was due to a poorly designed study. All right, bias is also due to a poorly designed study, and it overrepresents and underrepresents part of the population. Sampling error is a sample that doesn't represent the population, but we did not have a poorly designed study. For instance, if I put all of the names into the hat, all of the names of the students of Reagan in a hat and you drew 100 names and I drew 100 names, the likelihood that we have the exact same sample is not very good. The difference between that sample and what the population really looks like would be sampling error. And it happens, it's normal, we expect it, we can predict it. We really don't like it to happen, but we understand what to do with it. Sampling error is not a big issue. Typically speaking, if we were to draw 100 names from the hat, it'd be pretty close to the population. So let's just pretend that 25% of the students were freshmen, 25% were sophomores, 25% were juniors, and 25% were seniors. I put all the names in a hat, and I ended up with 23 freshmen, 25 sophomores, 26 juniors, and 28 seniors. Yeah, wasn't perfectly 25%, but because our method was good, it's going to be reasonably close. Reasonably close. So sampling error is not a huge issue. And the big difference between sampling error and sampling bias is sampling error is we'd use the randomization, we had a good study design, our sample just didn't perfectly match the population. There was a little bit of error term to it. We're okay with that. On the other hand, bias is we have a design flaw. And if we have a design flaw, we kind of even know which way it's going to impact it. Like, we know that if I stand out in front of a church and say, hey, how many of you believe in God? I'm going to overrepresent those who believe and underrepresent those who don't. I can pretty much know if I identify my design flaw ahead of time. So sampling error is the estimate of a population parameter that comes from a sample, and when we do it, we have variation from what actually is. So it's the variation from actually what is the population parameter. All right, for instance, if I want to know the true number of hours that Reagan students sleep on average a week, I could find an estimate by taking a sample of 50 students. If I took a good sample, one that represents the population of Reagan, my findings would be pretty close to the actual number of hours that are slept. However, the value I calculated is likely to differ somewhat, maybe a little bit, from the actual number of hours slept. The difference between my sample statistic and the population parameter is known as the sampling error or sampling variation. Please remember, when we calculate the number of hours I calculated from the sample is known as a statistic, while the actual number of hours that the population of Reagan slept is known as the parameter. Populations have parameters, samples have statistics. More specifically, sampling error or sampling variation is due to random chance and can be described by a probability model. I'll make sure you highlight that. And it can be minimized by increasing the sample size. And remember, with bias, increasing the sample size doesn't help. Bias data is a design flaw. Increasing the sample size just does not help at all. Sampling error is the recognition that every randomly selected sample from a population is likely to be different. If you draw 100 names and everyone in the class were to draw 100 names, even though all the students were in there from Reagan, chances are we'd have different names drawn. All right, because there are so many variables or factors within a population, it's nearly impossible to design studies that account for every variable without drawing a census, which we know is almost impossible to do. The federal government spending billions is unable to do so very accurately. Because we cannot count for all the variables, we involve chance in the selection of our sample to equalize the effects of variables that cannot be accounted for. Even with a well-designed study or experiment, even though we have a well-designed study or experiment, the sample statistic is only an estimate of the population parameter. All right, the sample statistic is only an estimate of the population parameter. The difference between that estimate and the actual value is known as sampling error. So if on average, Reagan's students sleep 7.2 hours a week, hours a night, and my study came back and said, oh, they sleep 7.1, that difference would be the sampling error. Once again, with sampling error, I can not eliminate it, but I can decrease the amount of error by increasing the sample size. Increasing the sample size does help with sampling error. If you remember, when we ran our simulations, those were completely random. But because there are multiple approaches and different ways to do it, we all got different answers. However, had we continued to increase the sample size so that we got to like samples of size 50 or 80 or 100, the difference between each method would diminish, because all of them were correct methods. It's just we were working with small sample size. So once again, highlight this, the amount of variation diminishes as our sample size increases. Once again, as a caution, do not confuse sampling error with bias. Sampling error is a term used to describe properly collected data. Once again, key word, properly collected data that didn't quite match the population. In other words, given a proper method of data collection, I would expect that my sample will vary somewhat from the population. That difference, or the amount of that difference, is the error. Error is normal and is predictable and can be controlled. The best way to minimize sampling error is to increase the sample size. And once again, we can't fix bias. We can't minimize bias. Bias is a result of a poorly designed study. And to eliminate bias, we must carefully plan and execute how we collect our data. So in other words, to eliminate bias, we have to have a good plan and a good study design. Whereas sampling error, we can minimize its effects by increasing the sample size. Sampling error will always be there. Sampling variation will always be there, but we can minimize its effects by increasing the sample size. Bias, we should be able to eliminate by conducting a well-designed and well-executed study. Very important to note those differences. Thank you.